I've received some goodies. I think I'd like to see what this one is all about. Let me see, I probably don't need a knife to get in there. So this is Limifrog. So it's a little gadget that I picked up from a Kickstarter. It's a 32-bit microcontroller based on an ST Micro with an ARM Cortex M4. It's got 512K of flash, 128K of SRAM. It's got a 64 megabit data flash, so that's separate from its code flash. Lots of sensors, USB, Bluetooth. It's got potentially a full color display and a LiPo battery. So let's have a look. We'll need this knife after all, a bit of tape. Okay, it's quite a lot of empty space in there, but let's see what we've got in these packages. So we've got a flexible connector, some kind of USB connector there. Okay, that's going to be some kind of programmer. I think you'd use this to actually connect it to a laptop and program on it. And I wonder if I can see what chipset that's going to be. So what we found here is an STM32, and it's an F103C8T6. This is an ARM Cortex M3, presumably flashed with code to act as the ST-Link chip. So let's see what the Limifrog board looks like. What we've got in this red packet here. Here's the Limifrog board. That's pretty small. What we've got? We've got a USB micro connector. We've got our ARM processor. We've got what looks like a programming connector there. That's probably the Bluetooth part. These are going to be some of the other sensors, which we'll have to investigate further. So teeny tiny little tack buttons either side of whatever this connector here is, and I'm interested in finding out what that's about. And this must be for a display, I'd imagine. Let's see what we've got. Oh, it's sticky, there's no tape. Oh, this, okay, I'm going to be careful with this. So this is my LiPo battery. Tiny little LiPo battery, which goes into that connector in the middle of those tack switches. So this might be very handy. I mean, given how lightweight it is, on a UAV, well, a quadcopter that is, on a very tiny robot. I'll have to find out what you can do with the I/O on it. So it says that documentation and instructions are available at limifrog.io/documentation. Please make sure you read the instructions to assemble the different parts of the Limifrog module and operate its physical connectors. So, or physical interface, connectors, switches and LEDs. So one of the reasons there might not be too much I/O is because there is so very many built-in sense and I/O. 3.7 volts, 500 milliamp hours for a teeny tiny UAV. I suppose that little formation there, where you've got the board and the battery back to back, takes up very little space for a controller. And it's also got instructions in French. Fantastic. This is actually designed and made in France. So, well, designed in France, potentially assembled in China, knowing how the world really works. I suppose let's get stuck in and see what we can make it do. And we'll go to limifrog.io documentation. They're talking about assembly. Now, if you've got the case and you've got the display, there'll be far more assembly. This is a pretty basic version where there is just a battery and a module. So assembly is going to be really a matter of plugging that battery in. Now, given that that battery's connector is a polarized connector, then there's really no way you're going to get that in other than the intended way. Now, the other thing that's interesting is this battery has what appears to be sense and limiting circuitry here, and a 3-pin connector. suggests, as well as power and ground, you've got a nice little sense, so you can probably charge it and safely know when it's charged and so on. It's just suggesting to connect the LiPo battery. It's suggesting where the OLED display, should you have one, which would go into this, like I suggested, this long connector here. Is it showing? It's not showing anything about connecting the programmer up yet. We can at least connect the LiPo, which I don't expect to be charged, but maybe it's ship charged. Only one of these is an on button. Oh! Aha! I woke it up. It's alive. It's doing something. So there's an LED there. Now they're suggesting actually going and mounting the battery somewhere up there, so you get an even lower form factor. Although I can imagine that would limit its Bluetooth usages. But at least we know it's alive. If present, the screen reports the access status of each sensor. Well, I don't have the screen, so I can't see that. So they're showing how you could use a Nucleo board, how you could use any other bits. Now this is their ST-Link compatible dongle. And here is it stuck in with these slightly swollen pins there. So I was going to add a segment in this video showing a screencast for getting the Limifrog development environment set up. And for which you're going to need an ST compiler, you're going to need, well, GCC, but a specific build of GCC, the ST libraries, the Limifrog libraries, you're going to need the ST-Link uploading gear. And as I started to do so, I think I'm going to make a longer screencast later on it because it's actually going to be quite a lengthy process. However, I mean, this has an underlying real message in that this is not easy to set up. And if you are going to go with the Limifrog, expect to invest a fair amount of time just getting a build, just getting it to build code that you can put on the device. It's something which, if you have used the Arduino or you have used one of these other kits, you may have taken for granted that they did all of this in the background. They do have some documentation which tells you which bits you need to install and where you can download them. At some point I'll add a screencast to the blog. Anyway, I'll see you next time with perhaps some more demonstrations on Bounce. So good night and thank you.